All right, guys, I want to welcome everybody here. My name is Kevin Kepp, and I'm the teacher for Engineering Design and Development over here at Prairie Ridge. I want to give you a quick rundown of a little bit about the course. We want to introduce our judges, and then as the groups come up, they're going to be able to present. First off, before we get into the logistics and everything and what we do in the course, I want to thank these gentlemen for being here. How about a quick round of applause for these guys for giving up their night to be here for our students. So sincerely, gentlemen, thank you so much for taking time out of your busy schedules. I know people are getting in the car in a little bit and driving all the way out to Ohio for some things, but it made some time to do this. So if you guys wouldn't mind, just maybe stand up, tell them your background in engineering, maybe a little piece of advice for our students, if you wouldn't mind. Tim, we'll start with you.
Tim Powers. I have an undergrad in computer science, and I also have an MBA. It's for the management side. What's interesting is I started out in industry, college of veterinary medicine, in computer science, and now I'm an engineering manager with medical devices. In between there, I moved from computers, and I was mainly in Motorola with cell phones and cell towers, to medical devices, and I was supervising mechanical and electrical engineers. So the bit of advice I want to give everybody is that once you get that engineering degree, the opportunities are out there. Just, are you willing to take that challenge? Because your education will give you that base.
Thanks, Tim. George?
I'm George Rykowski. I've got a BS in electrical engineering from U of I and a master computer science from Northern Illinois University. I've worked for Motorola for approximately 30 years. Now I'm half retired. I work at Roberson and Associates. Dennis Roberson was a CTO at Motorola, and it's a small niche RF company. And I would say that my advice in engineering would be to stay current. Always learn. Always, buy books, read up, keep current with what's happening, because it's so easy to fall behind. So do that. Okay?
Thanks, George. Tom?
Tom Key. My background, I have a bachelor's in engineering from the University of Illinois and a master's from Northwestern in engineering. I've been with one company my entire career. I've been with Sage Products, and always in product development there. I've loved it. My recommendation to you guys, if you love product development, keep making stuff and breaking stuff and get feedback from people other than people that you like, because they're the ones who are really going to form the end product that everybody likes, not just something that you believe. Good luck.
Thanks, Tom. Go ahead, Jim.
Jim Brown. I went to Purdue. I did a combination of mechanical and electrical. I was with a company for 25 years, so my whole career, and then most recently left and started my own company. So now I'm an entrepreneur, and I'm out with a couple guys doing our own thing. But I would agree with what Tom said in terms of advice: is don't be afraid to fail. A lot of entrepreneurs fail, but if you keep going, you'll eventually find success. And I think, like Tim said, having an engineering background allows you to do anything you want to do. I went into sales after about 10 years, and then into marketing and then business development. So by having that engineering background, it allowed me to do a lot of things.
Thank you.
I'm Brian Vanderlaan. I've been in the manufacturing industry for 29 years, degree from the University of Southern California, master's degree in this MBA. And I'm essentially responsible for growing our business development or commercial development with clients. We manufacture, design, and develop a rigid plastic packaging, so we're essentially injection molders. My advice would be to have no fear. Be all in, think outside the box, and keep asking yourself questions like why. So good luck today. Look forward to hearing more about your product.
Thanks.
Gary Berkland, was with Motorola, so we've got Motorola well represented here tonight. Was with them 37 years, took a 5-year hiatus to work with an entrepreneur in Southern California that had wireless networks across the globe. Had an exciting time. Figured it was going to put me in the grave sooner than I wanted to at that point. Came back, and I hate to say this, I want to say this, did substitute teaching in this district for a year. It was a little too slow paced for my A-type personality, and now I'm doing my farewell tour back at Motorola. so anyway, so I can see retirement in the future. I do not have an engineering degree, but I am highly technical. The teams I've led built cellular networks across the U.S., Nextel being one of them up in New York, Boston, corridor area. Verizon Wireless would have been the West Coast, or west of the Mississippi. So, to my friends in the engineering, if you're interested, get into it, and I echo everything that was said about engineering. The last thing you want to do is become stale in your knowledge base, because once you do that, it's so hard to catch up. There's engineering just quadruples day over day over day. It's amazing what you see, the technology that's coming out today, and what's on the drawing boards tomorrow. The only thing I would add to this is do what you like to do, what you're passionate. Engineering, business, or whatever, it's there, it's fun. But make sure your heart's into it, because that's the drive that gets you across the finish line, if there is one. So, nice meeting you all.
Thank you, Gary. Thank you, gentlemen, again. I appreciate your time. Also, a couple more quick ones. Of course, parents, thank you guys so much for A, being here tonight, and B, I know some of you guys maybe had some sawdust, some random things sitting in your garage for a while. We had that pallet project where maybe you had a giant pallet sitting somewhere in your driveway. Hopefully you didn't get a nail in a tire or whatnot, but thank you for letting your children explore and learn and break and build and do those things. And thank you for supporting them tonight. And of course the students, thank you guys for making every day fun, making every day interesting. You keep me up to date on things like Fortnite and all that kind of stuff and the news band, so I appreciate that. Why do we do this? Again, what you're going to hear tonight is the engineering design process. This isn't Shark Tank. This isn't about, here's a product and we're going to make millions on it. What you're going to hear is how these students work their way through the engineering design process. How did they come up with a solution? How did they test that solution? How did they make that solution better? So that's what you'll hear. They have 8 minutes to present and then 5 minutes for question and answer on that. But more importantly, why do we do this is we have fun. And I hope these guys had fun. I had a lot of fun this year with them. In the sense of, are they learning new things? Are they trying new things? Again, we don't have necessarily an app development class here. We don't have a materials engineering class. A lot of these students, what they've done is the things that they've had to do for the first time. They had to teach themselves some of these skills. So the idea of continual learning is something that we take pride in. Hopefully you guys all got an opportunity to try and dip your toes into something that you haven't got to do yet. And on that note, we're going to bring up our first group, and I'll formally introduce you guys in a second, but why don't you guys come on up here and we'll get set and we'll get underway.
Thank you for coming. Thank you.
Thank you for coming. Thank you very much. Good luck. Good luck. Thank you.
One second, gentlemen. Whenever you guys are ready. You gotta hit play.
Hi, my name is Kyle Hamilton,
I'm Eric Truitt.
And I'm Ben Schultz.
and we are Slope Sleep. So when we started this project, we wanted to think about something we all enjoyed and something we all had in common, and that was, for us, skiing and snowboarding. So then after that, we kind of thought, what kind of things do we all struggle with, and what kind of things do we think other people struggle with? And we all thought that we all struggle with using our phones on the slopes or when we had all our snow gear on. So from there, we sent out a survey to 164 people on various ski teams, ski organizations, or just students around the school who ski and snowboard, and with a series of questions asking them about phone usage while they were skiing. So, as you can see, a lot of the people who said that they used their phones while skiing also got colder while they accessed their phones, which that's how we kind of narrowed down to what was the main problem, not necessarily where you're putting your phone, but how to get to your phone. So we talked to Brad Johnson, a ski teacher at the University of Dubuque, who gave us some of his input. He thought it was definitely a problem, but he said he thought more amateurs would struggle with it because they're more likely to use their phones rather than professionals who are in the backcountry. So that got us to a problem statement. 76% of amateur skiers and snowboarders struggle while staying warm while accessing their phones due to the inaccessibility created by current methods. So these are some of the methods out there right now. There's the running armband, which I assume most of us have seen on people running, but the downside of that is that there's no insulation, so the phone battery doesn't work as well. On Apple's website, they said that an iPhone battery works less efficiently once it gets up below zero or below freezing. And also it doesn't have any padding, so if you take a fall with that on, your phone's pretty likely to get damaged or crack. The second one is smart gloves. So they have buttons in the fingers and on the gloves so that you can control your phone via Bluetooth. The downside with these is they're very expensive and they're not very insulated, so your hand's going to get cold anyway using them. And the third one is conductive tip gloves, which most of them are thin, but I know they do make ski gloves with conductive tip. But the downside of those is that if you're trying to type on your phone or press something small, they make it difficult because it's such a broad surface touching the phone.
So, what we realized is when we had our survey and consumer feedback, we realized that the three things everyone wanted in a product were that it would be comfortable, waterproof, and effective, and if it wasn't these things, they wouldn't use it. So when we made our decision matrix to see which of our designs or concepts would be the best, we found that we weighted these the highest. So once we calculated the decision matrix, we found that the arm sleeve and clip styles were the highest on being effective to solve our problem. So from there, we started to make some initial sketches and designs of what we would do. So for the stylus, it would be a 3D printed base that would be thick enough for a glove to be easily wrapped around it, with a tether in case of it falling in the snow, you wouldn't lose it, and a already existing stylus tip. And for the sleeve, it would sit on the forearm with a pocket for the phone and a hand warmer, which would help keep the battery warmer and therefore work better. And so from there, we wanted to begin construction, but we wanted to get some expert feedback first on what materials or any design flaws they saw. So we talked to Matthew Ray, who's an engineer for Under Armour, and Kirk Bresley, who started his own company, Anetic. So they recommended, or Matthew Ray recommended, that we would use spacer mesh for our product because it is insulated and it is padded. But Kirk Presley recommended that we would use neoprene because it is insulated and padded, but it is also waterproof, and being on the slopes, that was very important to us. So from there, we decided to make our first prototype, but unfortunately we did not have a very large budget. It was only $50, so we couldn't afford those for our first prototype. So we used old athletic gear, some foam, and some laying around plastic to create the sleeve. For the stylus, we 3D printed it, used a tether, and had the tip. One of the problems we ran into was that a stylus doesn't work unless your finger is physically touching it, because it takes the static electricity from the finger into the stylus, and then that makes the phone work. So an easy solution was that we'd wrap it in aluminum foil because it already has a charge. And although it was not aesthetically pleasing, it did work and solve our problem. And so once we had our prototype, we began to talk with some consumers on any flaws or improvements they would like. So we went to Raging Buffalo and Alpine Accessories and talked with some of them. And the consensus was that they really liked our design, and they liked that you didn't have to take off your gloves, and that the stylus was a lot more accurate than using the conductive fingertips. But some of the problems were that it wasn't durable and it wasn't aesthetically pleasing. And until we improved those, they wouldn't trust putting their very expensive phone in our product.
After we had consulted our experts and talked with consumers, we had to test the prototype to see if it actually served the purpose we were trying to do. So we ran various tests and discovered that with the hand warmer in the sleeve, it kept the phone battery at optimal running performance at 67 degrees Fahrenheit. And unfortunately, the materials we used were not strong enough, so we had to improve upon that in our second prototype. And the stylus had a constant voltage running through it, so it could be used reliably on the slopes. So after we had done all that, we had several changes we were going to make to prototype 2. Two of the ones I would like to highlight for you is the fact that we were going to use Kirk Presley's initial suggestion of neoprene in our second prototype. And we are going to use a copper tape around the stylus so it is more aesthetically pleasing and it still serves the same purpose. So in the second prototype that Kyle will be walking around to show you, there is a cover on the top of the phone to protect the phone from a fall if it occurs. On the back side of this cover, there is a hand warmer pocket so that your phone stays within that optimal running range. On the top side of the cover, there is a small pouch to hold any IDs, credit cards, or slope passes that you could need. And there are 2 holes for the elastic strap to fit through, so it can fit around almost any arm for a coat. Some final feedback we got on this prototype was very good. They really enjoyed the product. They thought it was an excellent, they thought it could be marketed very well. And when testing this prototype, it worked slightly better than our first one, which was very good. So it kept the phone within that optimal range, and the stylus worked more than 99% of the time. So you could rely on it if you were on the slopes. Some future improvements we would make if we had more time and a larger budget is we would use different styles of neoprene, different thicknesses and colors. And we would also use a reflective tape similar to that of a construction coat so that it could have a safety aspect to it. Thank you. Any questions?
So one of your initial requirements was it had to protect the phone. What did you do in your testing to prove that it protected the phone?
So we had actually done, so we took it outside when it did snow a couple times, and we actually did a couple fall tests with it. And so we intentionally fell and see how hard it could work. And we didn't have any problems. There's no marks on it. The neoprene is pretty thick. It's double layered on top. And then the arm and the other layer of neoprene keeps it pretty protected, so we didn't have any problems with it, any phone damage.
Along the lines of testing, did you take into consideration all the different situations that people would go through? Anything from lifts to in and out, to falls are the obvious one, but what other situations would challenge this product?
We took into account moving around a lot, so that's why we incorporated an elastic strap and the various size holes, so then if you have a larger arm or a smaller arm, you can adjust it to the proper size you need. And then with the elastic strap, you can tighten it down as tight as you feel necessary without the concern of it loosening up, because if you flex, then the elastic will flex with you and it'll stay in place. You don't have to worry about it falling off.
Did you test it on a bunch of different size people and different size coats to come to that conclusion?
Yeah, so it pretty much fits on every single coat we tried it on. I mean, me and Ben are very different sizes, and it fit both perfectly on both of our coats and arms. So.
And like for future improvement, I mean, of course we didn't have that much time, or we didn't have enough time and budget to make multiple sizes, but as a future improvement, we would make multiple sizes for different size arms or size coats.
Did you consider a stylus that would be integrated into the glove rather than a separate device which could get caught onto something, branches, whatever?
We did consider that. However, most people wouldn't be looking to buy a new set of gloves if they already had like a favorite set of gloves, so we decided to make our own stylus so then it could be used with any set of gloves you had. Or, yeah, as a future thing, we would consider making a set of gloves.
How did you, what materials are you considering for the substrate for the stylus?
I mean, I guess we're planning to use some sort of like hollow aluminum so that we don't have to like wrap anything.
The whole thing would be aluminum, you're saying, suggesting?
Yeah, so like,
Just the tip would still be the same.
so
Okay,
like,
I'm confused because you were talking about kind of a copper tape, right?
Yeah,
that's what it is
That's
right
what this
now.
is now.
Mhm.
yes,
So, but the final material would be,
like a hollow aluminum. Like
Okay.
most, like you can buy like $2 stylists at dollar stores and stuff, and that's what they're generally made out of. So
so that would offer you the conductivity that you're looking for?
yeah,
Yes.
Okay.
Was there any consideration of safety issues and how you deal with that? And then the other question I have is any consideration for the, I'll call it the audio aspects of the phone, the temptation to use that?
So for the audio, a lot of people now are going Bluetooth already, so that, I mean, if you go on the slopes, they even make on the helmets, they have like a patch in your ear that already is Bluetooth. So for that, a lot of people do listen to music, but Bluetooth headphones and all that have kind of taken care of a problem.
Okay.
And as far as safety goes, like we said earlier, the padding was really well. And a lot of people, when we talked to you, did like the fact that it was like stuck to your arm, so if you did take a really nasty fall, the phone wouldn't fall out or anything like that. And the stylus on like for the tether, it's not strong enough where like it would pull you or anything, so if something did happen, it would just break off.
One more
I want
question.
to just go back to when are we out of time?
One more question. One more question.
I have one more question. How did you come up with the design of the stylus? So I mean, it's an unusual design, right? I mean, where you've got a large hole, it appears that you've designed this so that your gloved hand can go through this, right? But for me, I'm looking at it and you're having to do this. Am I right about this, or am I wrong about this?
so that's one way to do it. So
Okay.
we made it so that you can have multiple ways to use it
Okay.
because we noticed with like a normal like cheap small stylus, they're really thin. So when you have gloves on, they're kind of hard to hold very well. So our first prototype, or our very first really primitive, it looked like a big crayon basically. It wasn't safe at all. So that was our, I guess that was our next rendition was, I mean, you could put it on your finger to use, or you can just hold it like a normal stylus, but we wanted to make it bulky enough so that you could, I guess, be able to use it when you have big gloves on.
All right, thank you, gentlemen.
Thank you, guys.
All right, we'll give you judges a couple minutes to fill out the comment section, the judging sheets, and we'll get on to the next group. Again, in between presentations, if you'd like, we got cookies back here. We got some coffee, the diet cookies too. So everybody knows. Some water. All right, gentlemen, whenever you guys are ready. Take it away.
Mr. Powers, thank you.
I'm Ian Anderson. And I'm Mitch Mueller. And we're the developers of Encore, an innovative way to track your tennis stats.
Now, starting off at the beginning of the year, we knew that we wanted to do something with athletics. Both of us being athletes, we also knew the importance of tracking your statistics. So doing that, it's often done with software applications.
However, being a tennis player, I noticed a significant lack of tennis stat tracking applications out on the market. Those that were out had very outdated features or didn't feature the in-depth shot analysis that I was really looking for to improve my game. So that's why we created Encore.
Now, we wanted to make sure other people shared these same concerns. So we sent out a survey to local tennis players, as well as various online tennis forums. And the feedback we received showed that people really weren't tracking their stats. But they felt that the app would help them start and continue to track their stats.
So this brings us to our problem statement, in which we found that 90% of tennis players say that they struggle to keep track of their stats during a match, and that causes them difficulty in identifying areas of weakness in their own play and the play of their opponents.
From there, we moved into looking at some existing solutions already on the market.
The first being Tennis Keeper. While Tennis Keeper is great if I'm just a single tennis player who just plays matches against my friends every now and then, it doesn't feature any sort of team tracking abilities for a coach to manage his entire team and all their stats.
Now, our second application we looked at was My Tennis Stats. And while it does have some doubles and team tracking features, it lacks some of the more modern and advanced stat tracking features that we wanted.
So this brought us to our first solution, which is a wrist wearable device similar to something like an Apple Watch or an Android Wear device that would have 6 programmable buttons that you would input your stats from right on your wrist while you're playing your match. It would connect to your phone via Bluetooth so you could see your stats at a later time, and would feature a lightweight plastic and rubber construction.
Our second solution is very similar to the first, in that it also has 6 programmable buttons. But this one attaches to the bottom of the racket. This presents an issue though, as many high-end rackets are balanced perfectly, and anything throwing off the weight could be a serious issue.
So this brought us to the final solution, and one that we continued into further development. This is a completely software-based application for your mobile phone or tablet that allows a coach to track their entire team's stats right on his phone and see those at any time, and then advise his team on how they should be playing their matches to win more.
We then brought these solutions into a decision matrix. Now, as you can see, the mobile application that we created scored the highest, as it offers the features that our users want. Both the wrist wearable and the racket attachment scored low, mostly due to our lack of ability to create a device that's up to the consumer standards.
And some of the other applications out there on the market scored fairly well, but due to a lack of either team tracking or a lack of in-depth shot analysis with success rates, caused them to score quite a bit lower than our mobile application solution.
Now, knowing which solution we were going to take forward, we were able to move into developing some mock-ups, which gave us the ability to visualize the user interface.
So this is something that a coach might see as they open up the app, and this gives us a great idea of what we want to look for moving forward into the actual development and building in functionality to the application.
And now onto that development, we used Xcode, which is Apple's software development environment for creating software for iOS apps. Now, this is where we built our user interface. A strong user interface is one of the most important parts of a mobile app, so we dedicated a lot of time to making sure ours was as smooth as possible.
So that brought us to our first prototype, which featured a basic UI that included 2 screen tracking, so it required 2 different screens to track each point. It allowed coaches to enter their teams and then manage their lineup from there, and then display any stats that they've tracked in a populated table of all of their statistics so that they can look at that and then analyze how their players should change their play to win that match.
Now, we then distributed this first prototype to some of our experts, namely Mike Stonis, the president of APOT, a software development company based out of Chicago.
And Jim Benson, the Prairie Ridge High School varsity tennis coach.
The feedback we received from them was that we needed to update our user interface. There was a lot of time being wasted from choosing the shot type to the success of that shot. We also knew that we needed to update the size of the buttons. When you're tracking a match, you want to be paying attention to the match and not to your phone. So having bigger buttons was definitely necessary.
Some other things that were really important were lineup management. A coach really wanted to be able to save his lineup right to his phone and micromanage that as he's traveling to matches so that he can put his players in the optimal position in order to win that match. Something else that was really, really important for coaches was the ability to save matches. If they can save matches, they can look at those matches at a later date. If they play that same team again later, and then they can improve upon their play before to win the next match against that team. Because in high school and college play, we often see that teams play each other multiple times within a season. So you'll see the same players over and over again and know where they're weak ahead of time.
Now, based on this feedback, we moved into our second prototype. Here you can see the redesigned user interface that integrated both the shot type and the success onto the same screen. And we also added the ability to save data.
So here's what a coach might see as they first open up the app. So this is their lineup as they can see it right now, which they can edit from their account screen at any time. Now as they move into track a point, they go to the play function in the bottom center. So let's take a hypothetical match, for example. Let's say their deuce returner hits a really nice backhand right down the line. That'll go in as a backhand ground stroke and then winner. Now the next point, their ad returner's up at the net. He's got a forehand volley, but he kind of mishits it and he hits it out. So that'll go in as a forced error. Now the coach can go in and hit the stats button and see the populated table of their stats. Stats that aren't tracked very often show up in green, as it's probably not really as interesting to a coach, but stats that have been tracked over and over again will show up in red, as that's an object of interest that a coach is definitely going to want to check out, and then advise his players on how to improve that play. From here, the coach can save the match, and then view that match at a later time, if he ends up playing the same team again. He can also make notes of what happened in the match. Like, take this first doubles match versus South, for example. The coach noted that the players fatigue quickly and start to fall off in later sets. That can be some really key information that if we play this first doubles from South team again, that we're going to want to know as we move into that match.
Now, due to the budget and time constraints of this project, there were some things that we were not able to implement, but definitely would want to in the future, so moving into some future development items.
The first and probably most important would be cloud saving. The ability for a coach to save their games to a cloud would allow them to see those games between devices, because we often find that coaches will carry multiple devices with them at once, say an iPhone and an iPad. And the ability to see their games from both devices would really allow them to have the freedom and be able to stay in our ecosystem long term.
Now, the second thing that we would add is the ability to share the stats. The coaches want the ability to share their individual player stats with that player. So right now, we're not able to do that, but in the future, we would definitely add that. Coaches also like to share their stats on social media and share the results of the match, so we would add that feature as well.
The third thing we would add would be player profiles. This would implement cross-platform versions, so that we have versions on iOS, Android, the web, so that players can go in and create their profile, similar to like you'd create an account on Facebook or any other social media site. The coach can then add those players into their team and then manage their entire tennis team right from on-court. This would keep people in our program long-term and continue to grow our user base.
We would also add things like a shot heat map, and as well as serve tracking to show where the serves are hitting and what's happening out of bounds.
So currently this is available on the App Store, and if you look, we've given you all a promo code to download it for free. If you scan that QR code and input that promo code, you'll get the app for free and you can check it out yourself. We currently have about 150 users and 15 weekly active users.
Thank you so much for being here. Any questions, please feel free to ask them.
You guys did a fantastic job. I just, real quickly, so is vantage point pretty key to where you're sitting to get an accurate reading on whether the ball that played was out or not? I'm just curious, nothing that necessarily has anything to do with your app, but...
Yeah, so if it's tough to see the line specifically if the ball is in or out, you'll know from what's happening in the point and the score that they call out whether that ball was called in or out. So like let's say if they put a ball in the corner and you're not sure if that would go in as a forced error for your player if they hit it in that corner and it was out, or if it would go in as a winner for your player if they hit it in that corner and it was in.
Right.
So you'll know from the point that's happening, but we haven't found any problems with vantage point or being able to see the match. You can generally
The only
pass
other
stands.
thing that comes to mind is a coach can only be, typically multiple matches are being played at one time, is that correct? So,
Yes, sir.
So how do you, have a coach taking multiple notes for multiple games at one time, matches at one time?
Of course. As you mentioned, there's usually a lot of matches going on at once, but there's also people that are not playing. So other players on the team are watching these matches, and they would be able to track the stats as well.
How are the stats currently being tracked without an app?
Oh, so yeah, currently a lot of coaches either eyeball, and so they'll just watch a match and say, well, I think their ad returner's backhand is kind of weak, but they don't really have any hard data to support that. And a lot of times it's easier to go to the players and say, look, he's hit 10 forced and unforced errors on his backhand. Put it to his backhand more and more, and they're going to win points. So they either just eyeball it, or sometimes they'll use a paper tracking system where they'll make tally marks on paper.
2 quick questions. What was the size of your survey pool?
149 results.
And then secondly, on the matrix evaluation, you didn't pick up on how you evaluated in the matrix. In other words, what was the criteria? What were the results in the matrix?
Yeah, so the
what
things,
I saw was bar graphs, but I couldn't relate it to.
Yeah, so things that we weighed really heavily in that were the ability to quickly update and improve on our design, the cost to produce, which is one of the main reasons we didn't go with the wrist wearable with a racket attachment, given our limited equipment here to produce those microelectronic devices.
How did you measure that?
So that was then based on a score of would we have access to these materials? Is that so that a score out of 10?
There's a scoring sheet that you.
Yes, there is. It's a big Excel spreadsheet though.
No.
Very difficult to read on a.
No, I got you. Okay, I just want to see what the process was.
Sure,
Okay.
absolutely. Thank you.
So did you actually try this with tennis matches, and how many different tennis matches did you do?
Sure. So we've been tracking matches all season with the PR team, both girls and guys. So we don't have
We don't have a solid
number,
Okay.
but it has been used.
So in that
here.
experience, you showed some futures, but what would you have improved just in the experience of trying to track shots?
So a lot of the things that we implemented from girls season to guys season over the course of like first prototype to second were the really key things that were slowing us down, like the 2-screen tracking where we now have it all on one screen. And the data table now being colored really helps to pinpoint those things, because when all the numbers are black, it's kind of hard to see which, 7, 5, 2, they all kind of look similar.
As well as the game saving. The coaches were just taking screenshots of the stats table, but that can be hard to organize, so having it built right into the app was a feature that they wanted.
Time for one more question.
So during a match, you have only one screen that you need to worry about, right? There is no switching between screens.
No, and
during a
that
match.
has reduced our time to track each point by over 80%, because we don't have to wait for that animation to load to the second screen.
Right.
So it's really easy, 2 quick taps, as fast as you can tap on your phone is as fast as you can track those points. So you're right back into the action of the match, and you don't ever miss anything.
Right. Okay.
Thank you, gentlemen.
Thank you, Mr. Powers. We really appreciate it.
Good job.
All right. Nice
Thank
job.
you very much, Mr. Markowski.
Nice job, Jack.
Thank you very much.
You bet. Nice job.
Thank you. Thank you, sir.
Good presentation. Thank you.
Thank you very much.
Appreciate your questions.
That's the clicker.
Yes.
Hi. Hi. Ian Remenschneider. Nice to meet you. Nice to meet you. Hi. Ian Remenschneider. Nice to meet you. Mr. Green. Nice to see you.
All right, Ian, whenever you're ready.
Hey, hello everyone. My name is Ian Remenschneider. I am the president of Safecar Charging. I'm also the CEO, CFO, co-founder, other co-founder, innovator, philanthropist, businessman, boy genius, sometimes. And my grandpa calls me champ. So, the problem that I found is that, or what I thought was the problem, is that when people are driving, they have a bunch of cords in the car, they have their audio cord, they have their charging cord, and it often becomes cumbersome and inconvenient to take your eyes off the road, get your charging cable, plug it in. It just takes too much time. So to validate that problem, I sent a survey out to, I think it was 67 people around our high school, asking them where they put their phone when they're driving, if they often find themselves having to charge their phone while they're driving, and whether wires became annoying. A study done by the University of Michigan said that as long as wires are placed out of the area of driving, it's okay, it's safe to use. This brought me to my new problem that I figured out. Teenagers, believe it or not, are not the best drivers. They're often distracted. I found that the average teenager, when taking their eyes off the road to plug in their phone, is really dangerous, and it takes too long for them to get their eyes back on the road. And that's what I'm trying to solve here. Now, some existing solutions to this problem are the wireless charger that newer car models are beginning to add in their additions. I know Honda is beginning to use it. It's air charging in their cabin. It does solve this problem, however, not many teenagers can afford a new 2018 Honda Pilot. The next solution I came across was a little cup holder insert. The only problem with this is that it takes away a cup holder. And if you're anything like me and have 5 unfinished McDonald's cups in every cup holder, that kind of becomes a problem. This next one is the suction holder I'm sure we've all seen to hold our GPS or our phones. The only problem with this is that it's big, it's ugly, and it can get in the way if it's suctioned to your windshield. I contacted some experts to see what they thought the design should look like. Kurt Shore, first off, the regional after-sales manager at Porsche, valued ergonomics and safety above all. He said that as long as the driver was safe while they're driving, it's fine. He's very passionate about cars, I came to learn through our 20-minute conversation over the phone. And he said that as long as everyone could use it, no matter their size and no matter their phone type, that it would be a good product. And the second one was Matt Riemenschneider. He's the engineering manager at Imperial Woodworking. He just guided me along the path of what materials to use, what hinges to use, what gauge wire to use, how to actually make the physical product. Some important aspects I thought the design should include is a low profile, so that one, it doesn't look ugly, it doesn't get in the way of anything, and as you're moving around the car, you don't accidentally break anything. It should be easy to use. The whole problem that I'm trying to tackle is that it's too inconvenient to get the charging cable and plug in your phone. So as long as the product is easy to use and doesn't take your eyes off the road, it would be successful. The functionality, it should save space in a car. It should charge a phone. That's one of the most important things about my product. And safety. I value safety over a lot of things in this product. As long as the consumer is safe while they're using it, as long as it doesn't have any glaring hazards with the design of it, it would be successful. So some of my concepts I came up with. The first one on the far left is a little cup holder insert with a curved coil around the edge of the cup holder that once your phone was charged, or once your phone was placed in the cup holder, it would begin to charge. The next one, in the middle, is a little mat with grips on the bottom that you would place on your dashboard and place your phone on top of, so that once you're driving and you're turning, it doesn't slip and fall all over the dashboard, and it would successfully charge. This next one is probably the safest out of all of those. It's a little console insert. Everyone has that little cubby in their car that they, sometimes put candy in and forget about later, like me. That would go in there, you'd place your phone on there, and it'd begin to charge. And you could basically forget about it while you're driving, you reach your destination, you open it up, your phone's charged. Final design, how it works. Actually, I can demo this. Go clicker this for a second. Final design, seen here, has a chip holder holding the wireless charging chip. The coil holder is connected by two 14-gauge wires to offer flexibility and positioning. And so it is attached to any surface in the car. The charging coil holder is bent into the cup holder, and as you place your phone over it, hold my phone the right way, is then charged as you're driving down the road. It eliminates any need to take your eyes off the road, to be distracted while you're driving, and it makes you a safer driver. This led me to my first two prototypes. The one is seen on the left, very crude. It was basically a 14-minute print using PLA material in our local school 3D printing lab, held together by electrical tape and colored on with Crayola marker. The chip inside, you can see, is connected by two, I think it's 4-gauge wire. It's also held together by electrical tape, and there are 4 solder joints holding the coil to the wires and the wires to the chip. It was functional, however, the problems occurred where we tried to flip the charging coil out of the cup holder and it just fall right back in. And the range wasn't where we wanted it to be. This led me to my second prototype. You can see a mock-up of it. I just wanted to get the dimensions right as we moved forward. And then this brought me to my official second prototype using a door hinge, which would easily allow me to flip the charging coil out of the cup holder. The glaring problem with this, however, is that as the charging coil was bent up, the chip slid out. Testing. Some important aspects I thought of the test is the device range. It works up to about ½ inch away. Phone models. Fortunately, it only works with Samsungs. Gauge efficiency. I thought that 14-gauge wire would be efficient in that it would be able to offer the correct positioning in the cup holder and to be able to still flip it out. Consumers, when asked about the product, said that it didn't look good. However, they do say that it's a problem that they experience. This is the final prototype being used. When plugged in to a normal 5-volt, usually cigarette lighter, it does. Thank you. Any questions?
Are there any considerations of the environment that it needs to survive in the car? In other words, extreme temperatures?
Yes, I found that when my first prototype was made, using the same coil and the same chip, it was a night. I was driving at 11. It was probably felt like 0 degrees in my car. It worked fine. The only problem is that the device range would be inhibited because it might not be warmed up enough. But as it is used throughout the car, it begins to warm up and it becomes as functional as it would be on a spring day.
What are the limitations of it only working on a Samsung versus any other phone?
Right. In order to save time, the only chip I was able to get was from an already pre-existing wireless charger. That just so happened to be a Samsung charger. And I found that usually when wireless chargers say that they work for both iPhone and Samsung, they're either lying to you or they must be geniuses.
So when you're using,
I'm sorry, the materials that you plan on using for, for this.
Right. Right now it's just made out of PLA material used from our school 3D printing material.
Right.
In the future, I'd like to use maybe a plastic molding so that it would, one, be able to create or be able to be created faster, and it'd be a lot more efficient and take less time.
Did you look into the types of materials that would be
no.
well suited for this?
Not specifically, no.
so did you actually take this out in cars, and how did the phone stay on it when you were making corners and braking?
That is one of the future improvements I would like to make. In that picture that you saw, it was held together by some double-sided tape. However, I'd like to use Velcro dots, little 2-sided Velcro dots.
Sure.
So one side on the device, one side wherever you want to place it on the car. It attaches to any surface, and it's easy to detach as well, in case you wanted to take it into another car.
What other future improvements would you make on this device?
One of the glaring problems I found is that over a long period of use, the coil becomes very heated and it tends to melt the material that it was in right now. So definitely a more coolant coil case, and then the gauge wire, the wire gauge, became a problem because as I was bending it back and forth over and over again, some of the wires within the actual casing began to snap and crackle, and eventually that's going to lead to some disconnection problem.
And you indicate that there are chips which apply to different phones. Is that true? So in other words, looking forward, you would want to charge other phones.
Yes, yes, yes.
How would you do that? How would you see yourself doing that, incorporating it into your device?
One way would be to either create 2 separate charging devices. I'm sure that there are some devices out there that claim they do charge iPhone and Samsung that actually work, but I haven't actually thought about incorporating both charging, or being able to charge both types of phones into the same device.
Okay.
Time for one more question.
You mentioned just along the lines of the question about testing. Your whole premise is that this is safer than the previous version. How do you go about testing that just general principle that plugging in something is less safe than what you're doing?
Well, it's not so much as the act of plugging it in, it's the time it takes for people to look away from the road, find their charging cable, plug it into their phone, open their case if they have a case like that, plug it into their phone, and get their eyes back up on the road. It takes too long, it's too dangerous, and the speed that some people are going, they cover too much distance in order for it to be safe. And what this is aiming to tackle is to just eliminate that time entirely. So you never have to take your eyes off the road. It's just take it out of your pocket, put it in your cup holder, and it's already charging.
Did you test that?
Yes, me and my friend, this past weekend, we went out on 14, and it took him 0 seconds to put his phone in his cup holder, and it took him about 7 to actually find the cable, plug it into his phone, get his ass back on the road.
Thank you.
Good job, Dave.
Thank you. Come on. Thank you for coming out.
Hey,
Thanks. All right, thanks for coming. Thanks for coming.
Hi, Matt Beach, whenever you guys are ready.
Okay. Just for warning, the beginning of this video is a little bit graphic. It involves some mice dying, so if you don't want to see that,
Turn away now. You
Not by these guys.
yeah, they were in the clips that I used. Hi, I'm BJ.
I'm Matt Drost.
And we're Happy Mouse. Now, they say the early bird gets the worm, but the second mouse gets the cheese, but we're here to change that. So our problem started when I found out that non-lethal traps aren't all that humane. So I wanted to see if other people, and I thought that was concerning, so I felt like I should see if other people shared that idea. So when we surveyed, we found 100% of people who preferred non-lethal mousetraps valued the life of the mouse. As you can see from these quotes, they value the life of the mouse, they do not want the mouse to be harmed, and they think that they have an empathy with the mouse, so they don't want this mouse to be harmed at all.
We also got in contact with some experts to see if they also saw this as a problem. Namely, Melissa White, who's a youth campaign correspondent for PETA. She said that this is absolutely a problem. She actually would recommend, coming from PETA, a snap trap over a humane mousetrap because the consumers who buy humane mousetraps oftentimes don't check them as they should, so it can spread out the process of them dying and they'll actually suffer longer. We also got in contact with Nick Fugate, who's an international sales manager for Nest Mousetrap Company, and he said this is absolutely a problem that him and his company are also starting to look into. They found that a lot of consumers don't take a look at the mousetraps as much as they should, and there often leads their humane mousetraps being less humane than a traditional snap trap.
This leads to a problem that online reviews from customers of non-lethal mousetraps have shown an inability to keep mice from being harmed. And so this brought us to our first design.
So we narrowed it down from a couple of designs, but this is our design that we went forward on. Basically, it's a box with plenty of windows so that the mouse doesn't suffer from anxiety attacks. There's plenty of air holes in order to allow them to breathe, to prevent asphyxiation and also hypothermia from their water in their own breath.
And of course, you would bait it with enough bait that it would prevent them from starving or dying of dehydration. There's also an Arduino in the back there that would alert them via buzzer, or that would alert the consumer via buzzer to let them know when their trap has been triggered.
So this is our first prototype. I was in charge of electrical work, and as you can see in the top right, that mess of wires that I made did not work at all. I tried to use like Q-chips, and just having so many wires made it so hard to debug and find the solution to the problem. And it ended up not working because I had to do a clock and I couldn't find a smaller capacitor for the buzzer. So we ended up just switching to an Arduino, which was a lot easier. We had just a few wires to put in for the buttons and buzzer, and just programming it was a lot easier than messing with all the wires.
I took more of a hardware stance on this side. So what I did was I developed the box. As you can see, it's got the window right on top to prevent that anxiety attack, and a limit switch in order for the buzzer to be triggered. What we found with this prototype, when we sent it out for testing, was that it was great at catching a mouse. It was terrible at releasing it. There is no way for it to, there's no easy way for you to release the mouse. There's no easy way for you to bait the trap. There's no easy way for you to clean the trap. This became apparent in our testing. So we did a bunch of testing on this mousetrap. We did a lot of friction tests, mainly on the door and also on the static friction of the cage to make sure that it was viable, that a mouse would actually be able to get into the trap without the trap just sliding across the floor. What we also did was we tested the battery life, and we found that to be way too short due to the Arduino. And we also tested the alarm effectiveness. So what we did for this was we set up our trap outside of a classroom during class, a very noisy one, our DE classroom. We set the alarm off, and I just waited. So after 7 minutes, I had a kid stand up, noticed that I was in the class, I wasn't supposed to be, and said, "Bud, turn off the alarm." We surveyed them, and they all said within 5 minutes they had heard the alarm, and this was a noisy classroom. So we did know that this alarm was an effective way to alert any consumers.
So we also got some expert feedback. The first being Mike Marchuka, who's an expert trapper with over 30 years of experience. He suggested adding a handle to the trap because people often feel uncomfortable like holding a box with a mouse in it, and just make the person feel more comfortable when releasing the mouse. Also adding a lug nut or some handle to the door so we can release the mouse more easily instead of having to put your hand in and to open the door. And the second was Brian Prescott, a material and cost product expert. He suggested using ABS plastic because it's strong, durable, non-toxic, and you can use groove bossings for the construction of it. But the caveat to this that it is a more expensive plastic, so we have to reduce wall thickness to reduce cost because consumers will buy multiples of these, and them being more expensive than some kill traps like traditional snap trap, cost is very important to be minimized. And the last was Melissa White again from PETA. She approved the Humanity trap, saying it was humane and she would prefer it over a snap trap, and she suggested using crackers and peanut butter because they're food that mice like, and peanut butter has a strong odor that will attract the mice. And she said that the color of the trap and the alarm wouldn't deter any mice from going in.
So on our next prototype, me and BJ ended up switching roles. I took more of an electrical stance on this one. So one of the big problems was that battery life we were talking about, and what that came down to is the Arduino just had far too much functionality than we even really needed. So what we ended up deciding to do is we scrapped the entire Arduino. We bought a Atmega 328P IC chip, and we set that down on a board, and we built our own external clock with a 16 megahertz crystal and 222 picofarad capacitors. From there, we were able to have all the functionality we needed. We had a timer so that we could have our buzzer go off. We had a limit switch, and we had the ability to program the Atmega 328P IC chip by downloading the Arduino bootloader, and then we could just download our script that we already had on the Arduino. Then, to save some space, instead of having it on an external breadboard, we put it on a proto board, and we built a shelf into the shell, so it all is nicely compacted right into the thing. No need to hassle with any breadboards, anything coming loose, anything like that.
So let's go to our final prototype, which you can see here. It has the handle, as Mr. Marchuka said, so people can hold it easily. A handle to open the door. The glass on the top, we switch from embedding it with screws to a T-slide to more easily access this. And to demonstrate how this works, you would have a mouse. It goes It goes inside the trap, and after 5 seconds of the door going down, being triggered, it will go off like that.
There we go.
So now you'll be alerted that there's a mouse. So then you would hold down the button to reset to stop the alarm because it's annoying, and then to release the mouse, you just simply open the door. And this guy's a little big, so he won't fall out.
It's a cat toy, not a skid.
Yeah, so you would go out somewhere like far away from your house. You would let him scurry out and do what he wants, and then you have a live mouse.
So future improvements for this, one of the big things we heard was Wi-Fi/SMS compatibility. We would end up doing this with a Wi-Fi module onto our board that would either alert an app that we would have to build or send you an email or text message. We also wanted to make it even more power efficient by adding one more resistor just here and there to make it last longer.
Thank you. Any questions?
So what is the?
7:59 time, by the way.
I saw that.
Tell you when the
All right.
voltage is going low.
Huh?
Is there like a
like an LED or
alarm
something to go off?
indicator gets really?
Afraid not, no.
Okay. Any thoughts on that eventually?
I do like that idea. Again, if we were to integrate the Wi-Fi compatibility and we did build our own app or set up a Twitter account to send you alerts, we could easily have it so, okay, the voltage is now dipped below, I don't know, 2 volts. The voltage is now dipped below 1 volt. So it'll our alert immediately.
What would you see as the projected cost, the ultimate cost?
Well, we did some calculations with the volume, and so the plastic casement costs about 25 cents to make, and
the circuit for the Atmega ICP chip, the 16 megahertz crystal, and the 22 picofarad capacitors together would cost roughly in the range of $4 or $5. So it's definitely going to be more than a traditional snap trap, but if we could minimize costs, especially on that plastic, especially on that circuit, it could fall right in line with a traditional non-lethal mouse trap.
Did you consider cycle testing the mechanism, the mechanical?
No, not too much.
Just as a mechanical engineer,
Yeah.
I mean, what fails are the things that move.
Yeah.
So when you do a design like that, you really need to make sure that you would cycle test it, because if it fails after 10 uses, obviously your customers will be disappointed.
Yeah.
So that's one thing when you're designing something like this, is to really take that into consideration, especially given that you want it to
That would
last a long
definitely be
time.
something, knowing that now that we would do in the future.
Thank you.
I got to give you a compliment. You were taking on quite the challenge to
Build a better
make the
mousetrap.
better proverbial mousetrap.
Thanks.
Good job with that, right?
In hindsight.
Yeah.
Rough choice.
What I guess my question would, as a consumer, I would be concerned at how long the 9-volt battery would last. You know,
Yeah.
what's the life of that? How often am I going to have to replace
Yeah.
it?
So like we were talking about, we didn't get around to proper voltage testing on that second battery, on the second prototype. We did end up changing it from 4 AA batteries to 9 volts, so that you do have an extra 2 volts, and we got rid of the Arduino, which just gets rid of all that functionality that you don't need. This one's on me. I totally forgot to put a resistor on our power lead, so there is room for improvement. I'm not sure how much it would come down to, but it would definitely last you a good chunk of time.
What happens if you're not home when it goes off?
The buzzer will be going off, and as long as the battery's still there. And so, obviously, if you're going to go away for a while, you accept that you obviously can't check the trap. So maybe using a lethal trap would be a more humane option during that circumstance, because it's all about, because traps are a last resort to having a mouse problem. So it's just what you were most more humane at the time.
I can jump in here. Nick Fugate also said that he recommends that you check your traps every 12 to 24 hours. So if you know you're going to be within a 24-hour period, and you know that you're going to be walking by or in a nearby room, you're definitely going to hear that alarm. So as long as you're going to be in that area every 24 hours or so, you're good to go.
Did you actually test this with live mice?
We attempted to catch a mouse, but we were unsuccessful in that.
We tested with both lethal and our mouse traps.
Okay.
We have one more group in this set. We'll come on up here in a second. Get all set up.
Well done.
Thank you.
Nice job.
Yeah, I can just, I'm gonna go down. Thank you all again. Thanks for your time. Thank you so much.
Good job.
Thanks so much for coming out.
Good job. Good job.
Do you want me to sit up for the presentation?
I can do it.
All right. Wait, is Nate not? Huh?
That's for Joe.
Nate's here.
Thank you. That was the longest 5 seconds of my life.
I was like, oh, I was like, I can see that.
Wow.
Well done.
Gentlemen, whenever you're ready.
This is the Gaming Wand. I am Jacob Beaver.
I'm Nate Link.
I'm Jacob Lawrence.
And we are 3L. So we've got our short video here to show our product.
I can't do it like this. I wish I could play with one hand. Wow, thanks, Gaming
All right. So the problem statement that we found was, of the 92% of disabled people that play video games, those with hand or arm amputations may struggle to use standard controllers.
So we talked to multiple companies on this. We talked to Special Effect, who is a UK-based charity who deals specifically with gamers who are disabled. Able Gamers, who is a US-based charity who does the same thing. The Veterans Association, and fun fact, current veterans play video games a lot, and unfortunately they have a high chance of losing limbs.
So, going off the problem statement, this brought us into existing solutions. So, the main one on the market would be in the middle, which is called the Grispa, and that's on Amazon for about $150, which wouldn't be too bad if it worked well. It's basically just a pad, and then you just push the buttons, but the problem is you can't really replicate something like an analog stick, which has accurate movement. So you're basically using 8 buttons to do something that one opponent should do.
In addition to that, this one is upwards of $700, a price that no one should have to pay to play a video game. And it also only works on a PlayStation 2, which is, if you know your video games, old, very old. So because of this, we came up with some necessary specifications that our device needed to achieve. A low cost, very, very important. Because the lower the cost, the cheaper it is so that we can get it out. And then it needs to be compatible with a wide range of devices. So some of those only worked with a single console that's 25 years old, maybe. And we wanted to make it so that everyone can use our controller for everything. It also needs to be easy to use, because that's the entire goal of this. You can't use a single-handed standard controller with one hand, because it's very difficult. I tried it in that video. That was actually me playing. And it also needs to be easy to manufacture, because that also keeps costs down.
So this brings us into our original ideas. So basically, the first one was just a DualShock controller, which is the PlayStation controller cut in half, which we found to be very difficult to use with one hand, although you could probably hold it well. The buttons get very crowded. And so from there, we went to more of a linear design, which you could hold with the handle and then use the buttons on the top, and then use the bottom on a table or on the right.
All right, so after that, we started really building our prototype one, designing what it should look like. And what we ended up doing was we took a standard Xbox 360 controller and we tore it apart, disassembled it, and used the components from that to integrate into our prototype one. One of the big things that we had trouble with was the big proto board down at the bottom. That has to stay together. You can't disassemble that part and you can't do anything about it. So that's where the base in the bottom left came in. So we strayed away from having an analog stick on the bottom and went more to a one-handed joystick kind of design.
From there, we basically constructed it using those specifications. We bought a controller, which is the thing that was just held up. We went on to just make a 3D model of what we thought the joystick and base should look like, and they were very tiny and didn't work very well. Here is a picture of the board that we needed to keep 100% intact, because if any of it's broken, it doesn't work exactly as it should. And over there is a picture of us soldering, and basically the solder job was soldering buttons to each other.
All right, so this is our first prototype. As you can see, Project Ugly Boy, that's what we nicknamed it. Because, as you can see, there's wires everywhere, it's hot glued together, there's cardboard. On the picture on the right, you can see that it's held up by a finger because the bottom joystick wasn't strong enough and it would just fall over every time you tried to use it. The buttons were hard to use. So that was very obviously our first prototype.
So this brings us into our consumer testing, which, if you noticed on the slide before, we added a paper cover over the buttons so that it reduced the pressure. And also, one thing we noticed with the base is that on some tables it would slide around based on the friction. So we decided later to fix that. And as you can see, the big mass of wire sometimes gets in the way of gameplay. Some more comments we got was that people felt like they were going to break the controller because of how delicate it looked. And the buttons on top were sometimes difficult to reach because the D-pad was significantly higher than the face buttons. And while playing Mario Kart, I found it very hard to steer around accurately because of the wire attached to it that restricted the analog controls. And here's some expert feedback. So Jesse from Able Gamers charity reminded us that comfort is a prime concern while gaming. So we wanted to make sure that the controller was very comfortable to use. And that kind of ties into what Barry Ellis told us from Special Effect. Basically, they said that we should test a wide variety of hand sizes to make sure that people's hands don't cramp up while playing, because that can be a major distraction. And also that we should keep the controller less expensive because most of the ones on the market are expensive and become just as inaccessible as a two-handed controller.
All right, so some design changes moving towards prototype 2. As you can see on the right, we extended out the base and just to keep it more steady on a table. And we also left it open so you can wrap the cable, as you can see here. We angled back the face buttons a little bit just to relieve pressure so the thumb isn't going straight upwards. And we also wrapped these wires around the base to keep it more steady. And some may say it inhibits gameplay, but from our testing that we've done, it doesn't inhibit any gameplay in the slightest, and all it really does is hold up the controller. So here's some actual pictures of it, as you can see right here, and there's still proto board that's exposed because we didn't really know how to cover that up. But as you can see, most of the wires from the face buttons and the top analog stick are very much so concealed behind the proto board, and everything is concealed well in the base as well.
So if we had more time to continue this and also a larger budget, our big thing would be hiding exposed electronics because the wires don't look great, let's be honest. More color schemes because that will draw in a younger audience that will then buy it, and also, fun fact, that's why Nintendo makes things colorful. Easy to press buttons because the current ones are very clicky and not the best to use. Actual triggers on the back, currently we just have buttons, and they're the same kind of crappy buttons. And a stronger connecting joint between the joystick itself and the base we have. Thank you. Any questions?
Other than the three of you, who else had a chance to do some of the testing?
There are several students that we tested with.
About 30.
Yeah. His family also helped test.
Did you have a standard, kind of a quantitative way of measuring? Was it easier than some of the other methods that are currently out there?
We currently only use the normal controller, and then we used our design and asked them to play it with one hand, and then basically which one they felt was easier.
Did you score certain things like comfort or performance or ease of use, just other ways of measuring?
Kind of, but not very
More in a verbal way.
Yeah, we mostly just took comments on things that we needed to improve upon.
Was it easy enough to use to where you would think that perhaps it would have a broader market? In other words, people who aren't handicapped would.
Possibly, if they got used to it. It's kind of difficult to get used to. I was able to play for a while with it, but that was also after playing with it for about 30 minutes.
Did you take into account, the placement of the buttons? I can only imagine in my mind that if you're handicapped and now you're only able to play these games with one hand, how fatigued your hand is going to become. The placement of the buttons and how far your fingers have to reach and whatnot. Did you take any of those human factors into account as you were building your prototype?
Yeah, actually, that's why going from our prototype 1 to our prototype 2, we angled the face buttons back, because some of the comments that we got from prototype 1 was that you had to extend your thumb up really high to try to hit those upper face buttons. But since then we angled it back and they were much easier to press.
Were there any gaming movements you weren't able to accomplish with this that the normal two-handed gaming controls would allow?
It was kind of difficult to go from viewing to jumping, for example, because you would have to take your hand off of one to get to another. But other than that, not really.
And especially with the ability to rebind buttons so if you want one thing to do a different thing on a different button, you can always reprogram that to do that.
Were you able to determine, general costs? I know that was one of your criteria that you were trying to achieve, that it was a low-cost manufacturable product, right? Is there any reason to believe that this would be more cost than a standard joystick?
There's a possibility that it would be more expensive than the standard controllers that are on the market currently, but there is no chance that it would be over $150 like the other ones, just because of how it's made.
And our current product is probably below the $50 line even, where most standard controllers are $60 or above. But ours, since we used existing pieces for it, and then 3D printed the rest of the parts, that really kept the cost low.
I noticed that you mentioned one of the controller competitors, or existing products was somewhere around $750 because you mentioned that nobody can afford that, and certainly, right? And so, you know, what was it about that controller that caused it to, you know, did it have additional features that yours doesn't have? You know, what would drive the cost up to $750?
I don't think it was produced at a high rate.
Yeah, I think it was mostly because it was custom.
Yeah, it was a custom controller. Right?
1Z, 2Z.
Yeah.
Low volume.
Yeah.
One more question.
You may have mentioned this just from the ergonomics, but, and this will show how little I know about gaming. I think sometimes you have to hold one button down to push another button.
Occasionally, yes.
So how do you do it with?
It's kind of difficult, but there is a possibility to rebind what buttons go where with a PC. Unfortunately, that isn't an option with an Xbox or Xbox One, which that also works with. But that is a possibility on a PC.
And also using one button to press another button down is also very rare to see in games. So.
Yeah.
All right, thank you. Okay, so as the judges add up the scores for this group, that brings us to halftime. So parents, you're more than welcome to stick around, ask questions. The students will be at their booths if you have any follow-up questions for that. Some of these judges are heading out, so how about one more round of applause for our judges again. Thank you so much, guys, for coming out. Students, great work. We'll pick back up here at about 7:25, 7:30 or so. Thank you. Hey, Kevin. Kevin can take it back.
I'd like to see that. My wife would like to see that.
You mind taking this out and like up there real quick, and then maybe be back in about 5 minutes. Kevin, let's stay up there and take a look at it. I don't see it. Thank you. Thank you so much for coming. All right, you're welcome. Safe. How's it going? Safe travel. All right, safe travel. Thank you so much. Thank you. They did a great job.
Yeah,
It's impressive.
yeah, all of them. Fantastic job.
The last one, the controller, to keep that working, what's it doing for us? I mean, just the fact that it worked, when they were showing the video and it worked, I was just amazed. And the guys with the I don't think they realize how. Just that, at this age,
They totally, they did their own code.
They did all their own code.
In Swift, Xcode.
I asked him, I said, "Yeah, we spent $1 million so that we could launch it to the I know, exactly.
Yeah, well done.
Thank you guys. Thank you very much.
Oh, great job. Wow, you can see all the
It was also
say what you want. You get it back.
Yeah, it's covered. Your time.
I was there.
How do we make money? We're gonna have you guys up here. Let me clear out some area. We still got some of the judges in the front.
Oh, okay. Dead center. Dead center.
Y'all did a really nice job. Yeah, that's a big thing, isn't it?
This is big time for you for yourself.
I hope that we're gonna, I hope these guys are. I'm seeing them again Thursday, so it'll be interesting to kind of see how how everything kind of goes. So it'll be interesting. It'll be good. I can't wait to see. You'll be there, right? Yeah.
So, Mark Elliott. Hey, Mark, how are you? Yeah. Come on in here. We're just getting cleaned up on the one. So, what you're going to hear is 4 They know that this is their time to sort of answer questions and sort of almost like a pretty fair-esque. You're going to get
Yeah.
So you said around 725, 730?
Yeah, so it's manual validation. People are asking
Okay.